Alright, this is Benjamin Johnson. This is my ALU, and I'm going to show you how it works. So the first four switches here are the 4 bits of input for input A, and then the following 4 switches are the inputs for input B, so switches 0 to 3 for A, switches 4 to 7 for B, and then switch 8 is also the carry-in switch, and then all the way on the end, switches 15, 16, and 17 are the input bits for the selector. Right now they're at 0, 0, and A is at 0, and so since the operation for 0 on the selector is +1, you can see 0 plus 1 is 1. As I increment A, you can see that every time, so right now the input is 7, and now it becomes +1. So we can see that the +1 is working. Now we go and we do the selector to decrement by 1. Because we're at 0, it decrements to 15, 1, 1, 1, 1. And when I increment this to 1, it's 0. When I increment this to 2, it's 1. 3 is 2. 4 is 3, so on and so forth. So we see that that is working. Next, we're going to go ahead and we're going to do the rotate right, which is 0, 1, 0 for the selection. So if we simply do 0, 0, 0, 1 for the input, when we rotate right, that would be 1, 0, 0, 0, which is 8. So we can see that that's working. Let's do, let's do 0, 1, 1, 0, which is going to be 6. And when we rotate that right, we get 0, 0, 1, 1. 0, 0, 1, 1 is equal to 3. So we can see that rotate right is working. So now we'll go ahead and do shift right, which is going to be opcode 0, 1, 1. So if we input 6, 0, 1, 1, 0, we can see that it's 3 again. So we know it's shifting, but is it shifting instead of rotating? Well, to check that, let's put in just 1 again. So we have an input of 1 going in, but because it's shifting instead of rotating, the output is just 0. So that's how we know it's shifting instead of rotating, and as we can see, it's working. And you know what, let's just go ahead and do one more test. Let's just do 15, 1, 1, 1, 1. As we can see, that it shifts right, which means that we have 0, 1, 1, 1, and so we have 4, 5, 6, 7 as the output, as opposed to if we were rotating, it would have stayed, you know what, and let's go ahead and check that. Yeah, see, if we had rotated instead, it would have just stayed 15, all ones. But because we're shifting, we drop the highest bit. Okay, so now we know that our shift is working. Let's go ahead and go to our next select input, which is going to be 1, 0, 0, and that is going to correspond with A and B. So let's go ahead and let's just start with 1 and 1. So as we can see, we have an output of 1 because both A and B are 1. If we do 3 and 1, 3 for A, 1 for B, or 0, 0, 1, 1, and 0, 0, 0, 1 for A and B respectively, we have an output of 1 because only both ones are toggled high. But if I toggle the 2 here for B high, now both of them ANDed together they are 3. If I just on B alone, if I toggle the most significant bit without doing anything with A's input, nothing's going on. So that's how we know that the AND is working. Next is going to be OR. We just go ahead and we just do 1, 0, 1 right there. So we still have, our 3s right now, but because we are now ORing, doing the OR operation, if I flip this, the most significant bit of A, input A high, we should see the 3 switch to a 8, 9, 10, 11 should switch to A. Or B. 10 is A, B is 11. So there we go. So as we can see now, because, you know what, and I'll go ahead and just, for B, we'll just make that all 0. But you see that doesn't change because over here, these switches are high because we're doing the OR operation. So we can see that that works. Next, we're going to do, the next select control, that is, which is going to be 110, which corresponds with the addition. And this is where we're finally going to start using our carry-in bit, which was switch 8. And so the operation is just simply A plus B plus the carry-in. So right now we have 1011, which is 8, 9, 10, 11, plus 1 from B is 12, which corresponds with C in hex. And then if we switch on our carry-in bit, we'll see that increment to D. There we go. So you can see that the carry-in bit is working, and that everything is adding up fine. But let me go ahead and show you. So right now I have 15 plus 0. Let me show you the carry out output. I did forget to mention the outputs earlier. So obviously, this hex, this 7-segment display is being used for the output, but also LED 6 right here is being used for the carry out bit. So if I have all of this high right here and I add 1, as we can see, because the output would actually be what you see right here on the switch, let me back it up. The output that you would see would be 1, 0, 0, 0, 0. So because the first 4 bits are 0, that's why we have an output of 0 here, but we have the carry out bit is high. And you can see that as I flip up some more switches, we have 15 plus 4, 5, 6, 7, 15 plus 7, am I doing that right? 15 plus 7, yes, is 22, so, well, I'm just going to assume that the addition is working because it's been working so far, but you can see that the carry out bit is working properly. Okay, and so finally that is going to bring us to the final ALU opcode or control code, which is going to be 111, which is A minus B minus C in, and right now everything is at 0, so we have an output of 0. But if we if we switch A to 3, well, it's 3 minus 0 because Cn isn't high, so output is 3. But if I put, let's go ahead and make B 1, now that just decremented from 3 to 2, and if I put C in high as well, well, that just decremented again. And then, so we can see that subtraction is working. Also, if I make it A minus B, 3 minus 3 is 0. If I increment the C in, we see that goes, with C in, it goes back down to F because you subtracted from 0. And so here, as you can see, when you have 3 subtracted by a greater number, in this case 7, you can see that the carryout bit goes high to show that we borrowed, as the instructions of the lab specified. So as you can see, the ALU is working perfectly, and it wasn't too hard to do. I got stuck on a couple of things, but once I got those couple of things figured out, then everything went smoothly, and yeah, thank you for watching.